Okay, here we go. Section 11.3, we're going to be talking about areas of circles and sectors. And there's actually two parts to these notes for today. It's 11.3 and 13.3. But just to keep things kind of easy, I'm going to put them as two different videos. Just to kind of, it's a little bit easier to check off what you're doing through this process. So, each video in itself shouldn't be too long, but it really is like one day of material, so just kind of keep that in mind. Okay, so let's start with areas of circles. Okay, y'all have used this formula before. So you've got your area equals pi r squared, obviously r being the radius. Okay, so that should be easy. This next part is something we haven't talked about, but we have talked about something similar to this. So here we're talking about area of a sector, and we've seen something similar to this when we talked about the arc length. Okay, so I want you to look at this equation. Look at this second equation. We won't really be using that first one, but the equation says that the area, now this is the area of the sector, so think about you're trying to, if you have a pizza, you're trying to get the area of just one of the slices. That's what we're talking about here. And so the area here is equal to x. That's going to be whatever your central angle is for that piece of pie. X over 360 times pi r squared. Now we looked at this when we talked about arc length, and we said x over 360 times 2 pi r. Okay, and that's because we were trying to get a piece of the circumference. Here we're trying to get a piece of the area. And so that is why here we're multiplying it by pi r squared, and before we multiplied it by 2 pi r. But it's the same thing. You're trying to get, okay, well, what degrees over 360 do you want the piece of? And then you're going to be multiplying it by the area of the whole thing. And that's going to get you just that ratio of that piece of pie that you want. Okay, so here we're just starting out easy, just getting the area of the circles. Okay, so again, we have area equals pi r squared. Okay, so here in this case, our r would be 8. Okay, and so we'll have area equals pi and then 8 squared. And so our area here would be 64 pi. Of course, most of the time we're going to want you to leave your answers in terms of pi, just because that is going to be the most accurate, the most exact. And then this is still units squared, if we want to get technical. Okay, number 2, again, here I already have the radius. So I've got area equals pi times 4.5 squared. Okay, and this, if you type this in the calculator, it's 81 over 4 pi. Again, if we want to keep that exact, then we'd want to get that simplified fraction. Okay, number 3, a circle with a circumference of 24 pi. Okay, again, we're still just trying to get the area of this. And so to be able to get the area, we need to know what r is. Okay, so the only information they give us is that the circumference is 24 pi. Well, circumference is, you can either think of 2 pi r, or you can think of pi d, pi times diameter. That's probably the easiest thing to think of here. So the circumference here is 24 pi, which is equal to pi d. Those pi's are going to cancel out, and so our diameter is 24, which means our radius is half of that, so 12. And so now if we get the area, that would be pi times 12 squared. So our area would be 144 pi units squared. But I ran out of room. All right, number 4. Find the circumference of a circle whose area is 36 pi. Okay, and so here we're wanting to find the circumference. So circumference is 2 pi r or pi d, whatever you want to say there. But they're giving us the area. So that's the formula I'm going to use as area. So if area is pi r squared, and that equals 36 pi, now I'm just going to solve for r. So those pi's are going to cancel. Take the square root, and so r is 6. And so now I'm going to take that and plug it into that formula. So c equals 2 pi times 6. So our circumference here would be 12 pi. And we're talking inches here, so inches. Oh, I guess those other ones up above, number 1, 2, and 3. Well, 1 and 2 gave us centimeters, inches and centimeters. So it would have been inches squared on number 1 and centimeters squared on number 2. Okay, so number 5 and 6 and 7, this is where we get into the area of the sector. And so we're just going to use that formula. And so we're going to have the area of the sector is equal to the degrees, the central angle here, which is 90, over 360, times pi r squared, since we're talking area of a sector. So pi r squared, so it'd be 4 squared. And if I do 90 over 360 times 16, that equals 4 pi. So that would be inches squared, since we're talking about area. Number 6, I see it gives me a diameter of 20. And so that means our radius would be 10. So I'm going to have area equals, the central angle there is 150. So 150 over 360 times pi r squared. So times pi 10 squared. And that would come out to be 125 over 3 pi. And then we don't have units here, so that would just be units squared. Pretty easy stuff. Okay, number 7, same thing, so how about we skip it? It's the same exact thing. All right, now here is where we get into finding the area of the shaded figure. Okay, so there's going to be a couple of pieces to each one of these. And so on number 8, in this case, we need to, what looks like a square, well, it is a square, because it tells you each side's 18. We're going to get the area of the square, and then we're going to get the area of the circle, and we're going to subtract the 2. Okay, and so on these, I would tell you the best advice is to keep things very specific and put some symbols. So here's what I mean by that. You either need to write out like the square or write out the big minus the small or whatever. I'll show you what I do. You do not have to do this, but what I'm going to do over here is I'm just going to draw a square. And I'm going to say that the area of the square is going to be, that's base times height, so 18 times 18, which is 324. Okay, so there's the area of the square. And then I'm going to go down and I'm going to say, okay, well now I need to get the area of the circle. So the area of the circle is pi r squared. Okay, well you need to know what the radius is. Okay, well I know the diameter is 18, which means the radius is 9. So that's going to be pi 9 squared, which is 81 pi. And so our area of the shaded figure would be, I need to take the square, which is 324, and I need to subtract out the circle, which is 81 pi. If we were asking for the decimal, then you could just type all that in, but if not, then you just keep it that way, which makes it really simple. All right, number 9. Okay, so here we've got this circle and we have the triangle. So if I want the area of the shaded figure, I need to get the area of the circle and subtract out the area of the triangle. Okay, so I'm going to say, all right, the circle would be pi r squared. Okay, well, right now we don't know what r is, but I do see that this is a 45, 45, 90 triangle. We should probably tell you that this is a right angle here. But that means that this is my x root 2 side, which is nice because it already has the root 2 on it. Which means that, sorry, hold on just a second. Okay, sorry. I've got to just erase what I just said because I don't even know why I just said that. Okay, so these are our x sides, and the hypotenuse is my x root 2 side. And so think about that that's your whole diameter here is going to be that you need to take what x is and multiply it by root 2. And so what I need to do is take what x is, which is 5 root 2, and I need to multiply it by root 2. So 5 root 2 times root 2, well, root 2 times root 2 is 2, and 2 times 5 is 10. So my diameter is 10, which means my radius is 5. Okay, so now we can get back to, let's get the area of the circle. So that would be pi r squared. Well, r is 5, so r squared would be, 25 pi. Now I'm going to get the area of the triangle, which is going to be base times height over 2. Okay, well, the base of this triangle is 5 root 2, and the height is 5 root 2. So I'm going to have 5 root 2 times 5 root 2 over 2. Okay, and so when you do that, well, 5 times 5 is 25. Root 2 times root 2 is 2. So 25 times 2 is 50 divided by 2. So the area of the triangle is 25. And so now, if you want to get the area of just the shaded part, you're going to take the area of the circle, which was 25 pi. And you're going to subtract out the triangle, which was 25. So these aren't super difficult. It just takes, you got to be careful. You got to take your time on these. All right, number 10. So number 10, let me make this bigger here. We've got what looks like to be like a little minion face or something. I don't know. And so anyways, I need to get the area of the big circle and then subtract out the 2 small circles. Okay? And so I'm going to first, we can just go ahead and get the area of the big circle because that one's going to be easy. So the big circle here, so the big circle is, okay, if the diameter is 14, that means our radius is 7. So that's going to be pi r squared would be 49 pi. Okay, so that part was easy. Now a little bit more work to get these 2 smaller circles. So let me just focus on one right now. If this radius here of the big circle was 7, that means where you see these 2 tick marks, that those are going to be 3.5. Okay, and so I'm going to get the area of just one of those. Okay, so the small circle here, just one small circle, would be 3.5 squared times pi. So that's pi r squared, which would be 12.25 pi. Okay, we don't just have one of those, I have 2 of those. So I'm going to multiply that by 2. So what we have is we need to take the big circle, which is 49 pi. Maybe it's not letting me write here. 49 pi. And I need to subtract out 2 of those. So that would be 24.5 pi. Well, the last couple we had to leave as is, but here we actually have like terms, and so 49 pi minus 24.5 pi is 24.5 pi. And I'm not writing units on these. Again, we should be, so this would be millimeters squared. So, sorry, just not going to do it probably on everyone. All right, number 11. And so this says solve for x. What's missing here is we need to give you an arc length to be able to do this, and we didn't give you one, so I'm just going to give you one. So we're going to say that the arc length is 49 pi. Okay, I'm just making that up right now. I just know that that will get us a nice number at the end. And so I'm just using that, okay? I didn't work anything out to get that. That just should have been written, and it wasn't. Okay, so notice what I'm saying. I'm saying arc length. So at the beginning of these notes, I went back and I talked about the arc length formula. And the arc length formula said that the arc length is equal to x over 360 times 2 pi r. Because we talked about that it's a piece of the circumference. And so what I'm going to do is I'm going to plug in what we know. And so we know the arc length is 49 pi equals, we don't know x, that's what we're trying to find, times 2 pi, and r is 14, so that'd be 28 pi. And so now you just do algebra and you solve for x. So I can see these pi's are going to end up canceling out. A couple of different things you can do from here. You can either do 49 divided by 28 and then times 360. You can think of that as 28 over 360, and you can multiply both sides by the reciprocal. Either way, I probably would do 49 divided by 28 and then do times 360. And if you do that, you actually end up with a really nice number of 90 degrees. 12 is very similar. So this says, given a sector and its perimeter is 22, determine the area of the sector. Okay, so think about this is like a piece of your circle. And so if this radius is 6 and the other radius is 6, and also this says 22 centimeters up here, that should say millimeters because that's what's on our picture. Not that that's that big of a deal. And so if that's 6 and the other piece is 6, but it's saying the perimeter of that sector is 22, then that leaves this piece to be 10. Now think about what that is. That's arc length. So again, we're going to use that formula we just talked about on the last problem. So here, because it wants us to get the area of the sector, and right now to get the area of the sector, I need to know what the degrees is of that central angle. So I'm going to say arc length, which is 10, equals x over 360 times 2 pi r, and r here is 6, so times 12 pi. Again, I'm using that formula because that's what we know is the arc length. Okay, we don't have any pi's to cancel out here, so what I'm going to do, again, a couple different ways you could do this. You could divide both sides by 12 and then multiply both sides by 360, or you can see that as 12 over 360, and then you can multiply by the reciprocal. Either way you get the same thing. But what you do end up getting is when you do all the numbers part, you get 300 equals x times pi. So if I divide both sides by pi, I'm just going to leave it like that for right now. So x equals 300 over pi. So now, if I want to get the area of that sector, that's what x is. So 300 over pi is my degrees, divided by 360 times pi r squared, and r is 6. So that'd be 36 pi. A couple different ways you can go from here, but really we're just working through some algebra here. Okay, this is a divided by pi times pi, so those pi's are going to cancel. And so now what I have is 300 times 36 divided by 360. And at the end of all of that, what you end up getting is 30. And that would be millimeters squared. Make sure that you take the time to actually type that in your calculator and don't just trust me on that. All right, here we go. Last one for this video. This is taking much longer than I thought it would. All right, what is the area of this shaded region? So here, what we have are these two circles. And so we need to get the area of all of it and then subtract out the area of the inside circle. So I'm going to say that the big circle, okay, the big circle, now this 20, that's pointing to just this piece. And so I know that this piece here is 10 already. So if I look at the area of the big circle, my radius of the big circle is going to be 30. So that's going to be pi r squared. So it's pi times 30 squared, which is going to be 900 pi. So that's the area of the big circle. Now I'm going to get the area of the small circle. Okay, and that radius is 10. So that would just be pi 10 squared, which would be 100 pi. And if I subtract those, so I'm going to take the big, subtract out the small. Sorry, I don't normally write this bad, but doing this on the iPad is not pretty. So equals 800 pi. So there we go.